Okay, so a few of you asked this week, why does pressure always decrease with height? So we're going to do a quick demonstration that shows why. So here we have just an idealized picture of anywhere on Earth. This green line is the ground, and then I have this arrow showing altitude. So 0 meters at Earth's surface, and will increase in height as we get higher on the page. Now, let's add a bunch of air molecules. Now, when I'm doing this is really important. There's a fundamental force that exists on Earth that is going to affect the distribution of our air molecules. I'll let you think for a second about what that might be. It's gravity. And what gravity is going to do is it's going to pull all of our air molecules close to Earth's surface. It's going to have a tendency to do that, right? Gravity is always pulling everything towards Earth's surface. Us, the moon, anything that's close enough for it to be affected by Earth's gravity will be affected by Earth's gravity, from our single atom to something as large as us or as large as the moon. So what that's going to do is we're basically just going to have a bunch of these air molecules, and they're not going to be the same size because I'm not great at drawing air molecules. But the distribution of these is what's important. Let's ignore the size of them for a second. And I don't want to make too many because that's going to make our job really annoying later. That one's an oval. But what I'm showing you here is that they're much more concentrated closer to Earth's surface than they are further away, right? They're much less sparse up here. Now, what is pressure? Pressure is the force of anything above being pushed down by gravity, right? What's the weight of the column of air above a point. So we can approximate that by saying, okay, well, what is the weight of the column of air above this red line? All right, well, let's count. Now I'm mad that I drew so many air molecules, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20, 22, 23, 24, 25, 26. I don't know. Let's go to 33, okay? I should have counted beforehand, but I did not. So we're just going to go 33. 33. Okay, so we have 33 air molecules pushing down on that red line. So that would equivalent to some kind of pressure. We'll just say 33. It's not going to be 33, but let's just say 33 for the purposes of this demonstration. Okay, well, actually, let's do yellow instead. Let's go up to mid-atmosphere. Let's go up to this yellow line. Well, now how many air molecules are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're down to 11. That's a lot less, right? The weight of the air at that point is significantly less because there's less air above us. In fact, there's exponentially less air above us. Now, if we go to the very top of the atmosphere, I don't know, let's use purple. It's cold up there. We've got like 2. I can count that high, don't worry. 2 air molecules. So our pressure is even less. So you can see as we're going up in the atmosphere, our pressure is decreasing because there's literally less air pressing down on us at any of these lines. Now you might remember this from the lecture. This is showing the same thing, right? You have all these air molecules really, really close to the surface. You have really high density near the surface, high density. And as we increase in altitude, our density decreases exponentially. And as our density decreases exponentially, so does our pressure, right? I can draw a line at any of these points, just like we did on my MS Paint, and count all these molecules, which I'm not going to do, but say it's 100. If it's 100 here, we might be down to like 50 here because of that exponential drop, right? And then down to here, we're only at like 5 or 6 as we go up in altitude. That was also shown here, right? We have this exponential decrease in pressure with altitude. So hopefully that helps and makes more sense to you. That decrease in density is really, really, really what's causing that decrease in pressure. And that is because it's a direct result of gravity. All right, hopefully that helped. Have a good week.